The ocean was calm just hours ago, a vast blue surface carrying one of the most powerful warships ever built across open water. A U.S. military aircraft carrier, a floating city of steel and firepower, moved with quiet confidence beneath a bright horizon.
On deck, fighter jets were secured in perfect alignment, radar systems sweeping the sky for threats that never came.
Then the weather shifted, almost invisibly at first, as clouds thickened and the wind changed direction without warning.
Far on the horizon, a dark, vertical shadow began to stretch downward from the storm clouds toward the sea. What looked like distant rain suddenly twisted into motion, forming a rotating column of wind and spray. It was not an enemy missile, not hostile aircraft, but a massive waterspout connecting sky to ocean with violent precision. Within minutes, the spinning funnel widened, accelerating toward the carrier's projected path. Sailors on the flight deck watched as the column grew darker and more defined, swallowing light around it. There were no weapons to deploy against this threat, no countermeasures capable of stopping rotating air and water.
The captain ordered a course adjustment, but a vessel over 1,000 feet long cannot pivot instantly against physics.
As the waterspout advanced, the sea beneath it erupted into chaos, waves rising and wind screaming across open water.
In that moment, the most advanced naval engineering on Earth faced something it was never designed to fight.
Steel, radar, and jet fighters meant nothing against a spinning column of raw atmospheric force.
Minutes before impact, the carrier strike group was conducting routine open ocean operations under standard weather protocols.
Radar screens displayed scattered storm activity, but nothing initially classified as a direct threat.
Aircraft were secured across the flight deck, chained tightly to withstand sudden wind shifts and heavy seas.
Below deck, hundreds of sailors continued routine duties, unaware that the atmosphere above them was rapidly destabilizing.
Meteorological systems detected a fast-forming rotational cell developing within the advancing storm front.
Unlike hurricanes tracked for days, waterspouts can organize in minutes when unstable air meets warm ocean currents.
Bridge officers recalculated the projected path, estimating a safe bypass if the storm maintained its current heading.
But atmospheric rotation intensified faster than expected, tightening into a visible funnel descending toward the sea.
Wind speeds across the deck climbed sharply, forcing immediate suspension of all flight operations. Deck crews moved quickly, reinforcing aircraft restraints and clearing loose equipment before conditions worsened. The carrier began a calculated turn, but its massive displacement required distance and the storm was rapidly closing.
Wave height increased as pressure gradients shifted, creating chaotic surface currents beneath the hull. Inside the command center, data streams updated in real time, showing the rotating column aligning dangerously close to their trajectory. The waterspout expanded wider at its base, drawing spray upward in a violent spiral of water and wind. Storm protocol was initiated immediately as alarms echoed through interior compartments and damage control teams moved to assigned stations. Watertight doors were sealed section by section, isolating vulnerable compartments in case of structural compromise.
On the flight deck, wind now exceeded gale force, whipping loose spray across steel surfaces in blinding sheets.
Crew members crouched low against the deck, securing final restraint chains as the carrier cut hard against rising waves. The rotating column ahead thickened into a dark, muscular funnel, its base churning the sea into violent turbulence. Crosswinds slammed against the island's superstructure, rattling antenna arrays and vibrating exposed deck plating.
Inside the bridge, visibility through forward glass panels deteriorated as rain and spray erased the horizon line.
The carrier continued its turn, engines pushing massive propellers harder as turbulence destabilized surface currents.
Electronic interference began to flicker across radar displays as dense moisture and electrical activity intensified.
The waterspout shifted slightly with the wind shear, aligning directly with the carrier's forward section.
Waves now broke against the bow with explosive force, sending walls of seawater crashing across the flight deck.
Aircraft trembled under strain as tie-down chains absorbed violent lateral stress from shifting gusts. The outer wind field of the waterspout reached the carrier first, striking like an invisible hammer of rotating air.
Deck lights flickered as power systems compensated for sudden electrical load fluctuations.
Then the spinning core closed the final distance, and the aircraft carrier entered the violent grip of the massive waterspout. The core of the waterspout slammed into the bow with a deafening roar of rotating wind and solid sheets of water. For a brief second, the carrier disappeared inside a spinning wall of mist, spray, and airborne debris. Wind speeds surged past 100 miles per hour, pushing laterally against the massive flight deck.
The ship rolled sharply to port, not catastrophically, but enough to send unsecured objects sliding across steel surfaces.
A fighter jet strained violently against its tie-downs as spray and wind hammered its wings.
Deck crew members clung to fixed structures, fighting to maintain balance as visibility collapsed to near zero. The rotating column dragged seawater upward in spirals, creating a temporary vortex directly over the forward deck.
Radar arrays vibrated under pressure loads as gusts tore across exposed antenna masts.
Inside the hull, shock sensors registered abnormal structural vibration as the carrier absorbed the impact.
Bulkheads groaned under shifting stress, yet internal compartmentalization prevented cascading instability.
The waterspout's rotating core moved along the flight deck, grinding across the superstructure like a spinning drill of air.
One aircraft's restraint snapped, allowing it to shift several feet before secondary chains halted its movement.
Debris lifted briefly into the vortex, then scattered violently across the deck. The carrier's engines maintained forward thrust, stabilizing directional control against the rotational drag. After nearly 2 relentless minutes inside the spinning column, the intensity began to weaken as the waterspout drifted toward the stern. As the rotating core passed beyond the stern, the violent crosswinds began to lose cohesion. Sheets of rain continued to fall, but the structured spiral of the waterspout started to collapse over cooler water. On deck, visibility slowly returned as airborne spray settled back onto the ocean's surface.
Carrier leveled from its earlier roll, its massive hull reasserting balance against the fading turbulence.
Damage control teams immediately deployed across the flight deck to assess structural and equipment integrity.
Several aircraft showed visible surface damage from debris impact and extreme wind stress.
The antenna arrays and exposed radar components required recalibration after absorbing violent vibration loads.
Crew members reported minor injuries, primarily from slips and sudden deck movement during peak impact.
Below deck, compartment seals held firm, preventing internal flooding despite external pressure shifts.
Engineering teams monitored propulsion systems closely, confirming that shaft alignment and power output remained stable.
The storm cell continued moving away from the strike group, leaving behind unsettled seas and lingering rain.
From a distance, the carrier appeared intact, still cutting through the water with controlled momentum.
Yet the event had exposed how quickly atmospheric instability can challenge even the most advanced naval platforms.
Waterspouts are often short-lived, but their localized force can generate intense rotational stress over confined areas. On that day, preparation, engineering design, and disciplined crew response prevented a dangerous encounter from becoming catastrophe.
As evening approached, the ocean slowly returned to a deceptive calm, masking the violence that had unfolded only hours earlier. Sunlight broke through scattered clouds, illuminating a carrier that had endured nature's concentrated force. Damage assessments confirmed that structural integrity remained uncompromised despite intense external stress.
A massive displacement of nearly 100,000 tons had provided critical stability during peak rotational impact.
The wide beam of the hull reduced excessive roll, distributing force evenly across reinforced structural frames. Internal compartmentalization ensured that even if localized damage occurred, cascading failure would remain contained.
Waterspouts, while visually dramatic, rarely sustain the prolonged destructive energy of large tornado systems.
Their danger lies in unpredictability, sudden formation, and concentrated rotational wind near the surface. Had the vortex intensified further or carried heavier debris, aircraft and exposed systems could have suffered far greater damage.
Had flight operations been active at that moment, the situation might have escalated into a far more complex emergency.
Instead, disciplined response and structural resilience allowed the vessel to absorb the encounter without catastrophic loss. For the crew, the experience served as a reminder that even advanced military power remains subject to atmospheric physics.
Steel, radar systems, and jet fighters offer no leverage against rotating wind and ocean spray.
Preparation, training, and engineering discipline are what stand between survival and disaster at sea. On that day, a massive waterspout tested one of the world's most powerful warships, and the carrier endured. Naval engineers later analyzed stress data recorded during impact to understand how force distributed across the hull.
Sensors embedded deep within structural frames captured vibration peaks caused by lateral wind shear.
The data revealed that the carrier's layered steel construction absorbed rotational pressure without exceeding tolerance thresholds.
Flight deck plating flexed within engineered limits, preventing fractures under rapid oscillation.
Shock isolation systems protected sensitive electronics from abrupt kinetic transfer.
Redundant communication circuits ensured command continuity despite atmospheric interference.
The propulsion shafts maintained alignment, confirming that hydrodynamic stability was never critically compromised. Even under rotating crosswinds, the carrier's massive inertia countered abrupt directional displacement.
Naval doctrine emphasizes constant storm preparedness, recognizing that weather can rival hostile threats.
Training simulations often include extreme sea states, but real atmospheric vortices introduce unpredictable variables.
Crew coordination during the event reflected rehearsed precision under pressure.
Damage control protocols functioned exactly as designed, minimizing confusion during peak turbulence.
Meteorologists later classified the waterspout as unusually large but short-lived in duration.
Its rapid formation and trajectory shift were driven by unstable air masses interacting with warm surface currents.
Unlike sustained tornado systems, marine vortices typically weaken once environmental support declines.
The carrier's survival depended as much on the vortex weakening as on structural resilience.
For the sailors on deck, the experience was a vivid reminder of the ocean's unpredictability. Moments earlier, the sea had appeared routine, almost peaceful beneath open sky.
Within minutes, that same horizon transformed into a rotating wall of atmospheric violence. Modern warships project power across oceans,
Yet they remain bound.
Steel and propulsion grant mobility, but stability ultimately depends on balance against wind and water.
The encounter demonstrated that preparedness must extend beyond combat readiness.
Environmental awareness and rapid decision-making remain critical for survival at sea.
The carrier resumed course with minor repairs underway and operational capability intact.
Behind it, the ocean showed no visible trace of the violent spiral that had momentarily dominated its surface.
Storm systems dissipate, but their lessons remain embedded in data logs and human memory. The sea does not recognize military rank, national flags, or technological achievement.
It responds only to pressure gradients, temperature shifts, and atmospheric instability.
On that day, preparation met nature's concentrated force and endured through disciplined response.
The aircraft carrier sailed on, a reminder that survival at sea is never about invincibility, but about readiness